Okay, so one of the first things, so we've got to add things to the drawable object. And the first one is I did a void tick. Yeah, okay. Let me just grab this. Make sure this is getting added to your document. Move this back over here. Okay. So the first thing that you'll need is basically is the public virtual void tick. And this is basically as we move on, we're gonna this is the equivalent to the update function. We will need a basically public static float. Let me grab the definition. Put this all the way at the bottom now. Okay, so the first thing that we're going to do is we're going to generate be a vector 3 and it's going to be basically endpoint minus start point. And now that we've got that, there is basically, it's asking to convert you from a vector 3 to an angle. You're using what's called ATAN 2. And this is going to be in your math F, ATAN 2. So this is arctangent. So basically, to give it a float, this is, and you can go back through what specifically, but ATAN 2 is the version you want. It's basically going to return back an angle in radians. So basically, it's going to be our line vector dot y, line vector dot x, and float radians is going to be equal to that. And then finally, all we have to do is now return radians times mathf radians to degrees. All right, it's going, basically they're using again, a value of 57.29. Basically it is pi, basically is, let me just grab this. Put a comment, radians is equal to pi over 180. That's basically what that value is. I'm sorry, I've got it backwards. It's 180 divided by pi. So that's basically, hey, we're returning. We've got a vector here. We have a vector. We've created a vector here, and now we have a point that's, we have now basically an angle that relates to that. So we are. This is going to be important. I know that we have. Another version of this is line to angle. I'll make this public. And literally what we're going to do is just take the V3 to angle, return, start, line dot end. And there's a case where maybe these probably should have been put into the line class. That there's a good case where that probably might make more sense being in the line class itself. For our purposes right now, I'm asking you to, I'm asking to make changes to this object, this class already. So that's why it's going here. All right. So far so good with. So basically, we are going to use this effect at some point. What we'll do is actually one of the things that you'll do is you'll create a vector. One of the things we're going to do is we're going to create an object that has basically it's going to be a square with a facing point.
All right.
I will give you that object, so you don't have to create that. I mean, it shouldn't be hard to create it, but I'm going to give you that. I'm going to create that object and give it to you. So that's it. You're going to see things that, new files attached to this document. So, drawing this drawable object, I'm going to ask you to do. So the stuff that, the tick, these functions right here. And the next one, I'm going to ask you to actually create. The last one is going to be is this rotate point function. All right, so it takes three. So we need to assume three things. Basically, what is the point in? Where is the center of it? And what is the angle? I'm going to move this around. So this is going to be, we're going to do a vector 3. We'll set this to point in, just start right away. Actually, so we'll start actually point in minus the center. There you go, lowercase c for center. Okay, so the idea here is that we're taking the point. So if we're not at 0, 0, 0, let's get back to 0, 0, 0 in terms of that with that positioning. It means so again, I'm going to put this if not at center, translate back. If not, sorry, not at 0, 0, 0. So translate back to the origin. So a lot of times you'll see, the center being vector 3. Actually, let's take this and let's make this even easier for ourselves. Let's reorder. Let's put the center as the last parameter, and we can then assign it to vector 3 dot 0. Must be typical kind constant. That's not what I wanted. New vector 3. Okay, so it's not gonna, because it's I'm dealing with properties right now. So I was trying to do a default value. It's not gonna let me do what I want. And then again, what we're gonna result. So we're gonna return result plus center. Okay, so the idea is that, okay, so back to where we are. We first have to translate to 0, 0, 0 to do our rotation correctly, and then we're going to translate back to the center point. All right. So let me see. So we know this is going to be is it capital? Yeah, it's capital. We need to, this is point in, actually want. Do I want to? Yeah, let me see. It is changing both of it. So what we do need is not this to be the result. Is actually point at 0. Means we need a vector 3 result. This is going to be, we'll just do vector 3.0. Okay, so x new here, this is again, in the document you'll see x new. This is going to be result.x, and this is going to be result.y. This allows us to grab point at 0 here, dot x, dot y, and then this is going to be mat f dot capital S sign and the angle. So now I could go in, let's correct these. Okay, so this is basically, I mean, this is the logarithm. For the sake of this video, I'm not going to go over the math behind it because I've given you documentation about how we get here. So it is perfectly fine to just grab. I mean, this is a, you know, it's a math course, but it's also a programming course. So I'm focusing on the programming side right now. Here, basically, I'm telling you, here is your answer for this problem. And I'm basically saying, if you want to dig in deeper, there's more information to be had here. All right. Again, the big thing here is that you've got to translate, again, given the point here, given a center point, given the point that we want to change that by a certain angle. I believe, and I'm blanking whether we're on degrees or radians at the moment. I think we're in radians, to be quite honest, because yes. Sine, cosine, sine all work in radians.
Yeah, because everything's using radians up to this point, so I'm concerned if it was radians.
Let's just rename this to be angle in radians, just so that we have. So let me
clarification.
Yeah, let's clarification. So I'm gonna go in. I'm going to update. So use this version of the method, and I'm literally gonna grab this code right here. Actually, I need to grab. Sure, yeah. Yeah. Yeah, I'm gonna grab all this code. I'm gonna. All right. So I'm gonna give you the code for this. Again, the idea here is that we need now this rotate point. Now that we've got that, we need to jump back up here. So again, we've done scale, we've done position. Now we just need to go and rotate. So the next that we need to do is basically is sorry. translated line dot start is equal to rotate point. The center is going to be vector 3.0, because again, where we are at this point, in this scenario, is that we are inside the grid space, and the object is starting at 0. There's a 0, point to the object already. So where the center is at 0, already. So we're not positioned somewhere on the grid. We haven't dealt with that scenario. Again, it's going to be translated line start, and then finally, there's a rotation. And I'm going to say, for the sake of argument, we're just going to use just the rotation as radians. This is one of those. We're going to assume that. Let's jump in up here. We'll leave this as radians. We'll come back to that one moment. We'll make a utility function. And I have gotten systems got drawing. Get rid of this. Do we need? No, we don't need the glint. Okay, so be mindful that Visual Studio is going to try and add stuff. So, all right. We need to do this again down here, but we need to take the endpoint, and it's really just changing these values. So, however, yeah, basically, whatever we need to do to start, we need to do to the end as well. It's pretty much the mantra with the line right now. And that basically, now that we've done that, I mean, now we've got that set up. Let's save. Let's go to. All right, I'm going to go jump to the 03 grid. This will be done in a 04, a Lab 04 grid class. So. Grid. Okay. Here we go. So we did create a diamond in this case. And then we scaled it. This is the one that we've got the scale. And I added a rotation of 45. This is, again, we're going to go in, and what we really want is math f degree to radian. So this is so basically this is bringing us back. So this is multiplying this by radians to get the correct. So because we're working in radians now. Just for argument's sake, this is public float. Now this won't be static because we need this to operate on the object itself. So get and public void void set rotation in degrees. Okay, so get rotation degrees. This is again is going to be our return rotation times math f times radians to degrees. And I'm just gonna, because it is a mathematical operation, and I'm paranoid, I'm going to do it like that. And then here, this is going to be rotation is equal to the degrees times math f degrees to radians.
Can you just call get rotation in degrees?
What was that?
Can you use get rotation in degrees in set rotation in degrees?
No, because we're setting it. We're setting the value.
I mean, like,
we are setting rotation.
Okay.
This is getting the rotation. So, these are utility functions. Let me just add those. Yeah, let me add these, make sure that these are in. There we go. Okay. Okay, cool. Okay. All right, so let's go back. Let's actually do this correctly. So here's the lab3 folder. I'm just going to create a model behavior script called lab04 grid. Let's go into scene manager. I'm in the test scene. Let's go to and I'm going to go file, save as lab 04. And I'll just leave this in this folder right here. The event system, no, that's not what we want. Scene manager. So we're going to remove and put in the lab 04 grid. Let's go back and let's get things up and going. Let's close all but close other tabs. There we go. All right, so let's open up the 4 grid. Again, this is going to be the drawable grid. These go away, and then we can grab that much. We'll paste this in. There we go. Won't need the drawer arrow, but don't need parabola anymore. Scale 20. Use the given. Use the given. I need to get out that. At scale of 20. 3. Let me grab this. We are 2010. Okay, and then okay, so let's go back. So basically, I want you to set up the diamond as it is. Diamond at scale of 20. Diamond at scale of 2010. So it's then at 2010 rotation of 45 degrees. All right. We won't be done yet. There will be one more that we'll do. Okay, so now that we've got this in play, let's go look at you. Now that we've gone, the one thing that we do want to do, make sure you do is here's the panel. Make sure that you update the lab, so it's pointing at the lab 04 grid class. So that's the one thing you have to do. Here we go. So let's go back to, let's jar only the axis only, just to make our lives easier. And we'll zoom in. I need to go bigger. All right, so we're zoomed in 100 units, just so you can see that, hey, here is that diamond. Again, it's a very small diamond. So next one is scale 20, so let's cut this down to, so here is the diamond. I'm actually going to go back down to grid size of 10, because the next one is going to see it scale 20 on the x-axis, 10, and then we've rotated it 45 degrees. So did I really want that? Let's go. So let's go in and let's do this one more time. $90. Let's do drawing axis only. 45, 90 degrees. So we are getting it. So far so good. All right, so we are getting rotation done correctly. All right. this is where you're going to get this. You're going to get an update to the an update to the actually, let's do. Where did I put the diamond? Durable object. Show scene. Where's here? Where did I put it? Durable diamond. Where is durable diamond? Is in the lab 3 folder. Okay. Okay. So this is where things are going to get a bit crazy. I'm going to create a new, basically a new behavior script, and this is going to be rotating diamond. All right. Let's just jump. Let's bring up the drawable diamond. So basically it has the initial, so we've got initialize. Let's bring up the drawable object. Again, make sure that the tick is virtual because we're going to basically what we're going to do is going to over here in the, where's the rotating diamond? Well, oh, did it? Okay. It renamed the file on me, and I was wondering if that was going to cause a problem. I'm just going to save everything. Let's just jump back to, this is going to be basically, this is a drawable diamond. And all that we are doing in here is we're basically going to do is a override. And this time we're going to override the tick. We don't need the base because there was code. But basically what we want is public, we'll just make it public float, rotation rate. We'll say, I'll do 360. I'll start it as 90. So basically we're saying is that this is going to rotate 90 degrees every second. So what we need to do is a rotation is plus equals. First thing that we need to do is rotation rate math f dot degree to radians if I spell it correctly. And that needs to be multiplied by time dot delta time. So we didn't have to pass delta time, like I know like Unreal passes delta. That's for the reason they do it. With Unity, we don't have to because they put that into that time structure. And I am going to because I'm that. Actually, I'll just gonna put it all in one parentheses. So we need to convert it from degrees or radians and then multiply by time delta time. And basically this is, so we're using the object as created. And off we go. So we'll save that. Let's jump back. Let's go back to our for grid. For sake of argument, I am going to grab, actually I'm going to put it up front first. And this is going to be not the drawable diamond, this is the rotating diamond. And just putting this right here will help us test it. This would probably go down at the bottom. So we can go through. All right, so we're going to go back to Unity, and we're going to press play. And it's not going to operate. The other thing that we needed to do is rotating diamond at scale 2010. So we need to go grab this line of code and add that in here. Just to make our lives easier, I'm going to turn on drawing axis only, so we're only getting the axis line. Oh, what happened? Oh, there we go. All right, so nothing's happening. So we have implemented the tick function. The thing is that the drawing object is not calling any ticks. All right. We are now, I'm going to go into the drawable grid class. You are going to get a new drawable grid. I'm going to give you the diamond. I'm going to give you the drawable diamond and the drawable grid. You will have to create. I'll give you the rotating diamond. Yeah, it's the low hanging fruit. Let's see. Okay, let's go into the drawable grid class. All right. We're going to put a public bool. Call it tick all scenes. So basically, the idea here is that when this is true, every single scene is going to get ticked. If it's not, so basically, scenes, draw scene, don't use the variable. So we're going to have a function here. We're going to call it tick scenes. And I'm going to basically, essentially, this is the update. So get input, update. I mean, this is start. Get input, which we've established. Tick scenes, which is the update. Then we'll draw the grid, draw the scene. So this is public void tick scenes. If, and I'm going to go back and I'm going to rename this with a is in front of it. Yeah, naming booleans is a form of a question. It's like Jeopardy, but but you don't get points or money. So if we're ticking all the scenes, so this is going to be basically an else. I'm basically going to make a public void tick scene take this scene. Yeah, that will make it easy because this, again, a scene is a list of drawable objects. So this is going to be scene. Okay, so what this allows me to do is to go up here and basically like, hey, for each yeah, we'll use the var. We can then tick this scene. Again, I've used the var, but I'm going to go up and just basically use that correctly. All right. So in this case, we're going to go through all of the scenes and call tick. In the else, basically, again, we have at the scene index. So essentially, it's going to be down here. It's going to be tick this scene, scene list, scene list index. So pretty straightforward. Now, logic so far. So now we need to go in, and we need to go and basically then for each drawable object in the scene, object dot tick. You could, yeah, that's pretty much it. We just go into the individual scenes and go through each object and tell it tick 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 tick.
Okay, so that's like for animations and stuff, right?
Yeah, so the idea here is that the issue that we had previously is that we inherited to the rotating diamond, but it wasn't moving. It's because it wasn't being ticked. And so I could have you write this code. I'm going to give you, I could have you write this code, but this is a, hey, software engineering. This is like, I'm showing you and giving you this code because this assignment is not about the organizational piece. This is a software, and because I'm having you work in a particular way. So if we press play now, you'll see that, hey, it's rotating. 1, 2,
cool.
3, 4. And now it is rotating. And then I know we've got another one.
Wait, do it again.
Now the thing here is that when I go away, it's not going to get an update. That's why if I turn on, it will now update. So basically it'll update now. And that's part of where we need to go. So that's the first thing that you need to do. All right. I'm gonna give you another. We're gonna create another object. We'll call it facing box. All right. So in the case of the facing box, again, this is a drawing object. I'm going to go back to the drawable grid. I want to make sure. Division count. Where is my Etsy? Get input. Where Okay. So what I want to do is I want to promote. So one of the things we need to do is do we need to pass the grid? No. Let's make a public static drawable grid instance. So we're making this class a singleton for our purposes right now. I'm literally going to go in and basically do a void awake instance. So it's lazy singleton. I'm going to then go in and basically make a public vector2 mouse three zero. Go back to my input. So I'm basically going to basically set the mouse position to. I'm going to grab this every frame now. And another reason why I'm going to give you this code. Basically, all that we need to do is plug that in right in that way. Because now that I've done this, we've got now a way to get that mouse position. Get that mouse position. We're going to jump through a lot of hoops to get this to work.
Oh goodness.
Yeah, because so the idea here is that
Didn't we already do that?
No, sort of. Well, we'll talk about. So let's basically let's go grab the durable diamond. Let's bring an initialize. I'm gonna make this 1 1 negative 1 1. So I'm gonna make this basically a box to make our lives easier. Negative 1 1 negative 1. Negative 1. Negative 1. 1 negative 1, and then 1 negative 1 back up. Okay. Let's start with that, and then we need one more line from 0 0 1 0. Okay. So let's go back to grab this. And we'll make a new facing box. I'll do 10 by 10. And then we can, let me see. Press play. Okay, so we have the box. We have, again, that line right here. So the goal is that this is going to rotate basically rotate around basically where the mouse is. So let's now jump back to the facing box. Public tick. And it needs to be an override. Sorry, public override void tick. Let me see. So the first thing that we need to do is figure out, we need to get to be a vector 3. Facing vector is going to be equal to, now we know that origin and the mouse position are going to be in screen coordinates. So we can use that to our advantage. We can do the calculation there in screen coordinates and get our, basically what we want is going to be our vector. So this is going to be, the facing vectors first we need to, it's going to be the variable dot instance. Mouse position minus why is it yellow between these two? Vector 3. I'm going to go back to the drawing grid and I'm going to upgrade the variable from vector 2 to vector 3. Again, we know that we can shove a vector 2 into a vector 3. There we go. And the z value will be 0. So we'll be fine. That will solve our problem right there. Where is it? Here's the facing box. Okay. Oh, there we go. All right, so that's our facing vector. We can then put into variable object. It's going to be blanking. Where is durable object? So V3 the angle. I mean, we could have. I mean, actually, we could have. Yeah, actually, let's grab that. Actually, we could instead of we could have instead actually done V2 angle. Start point basically being the origin, and then rotation. Yep, I misspelled it. Okay, so I mean, we could have done that. I mean, the V3 day angle, but basically, I can now just shove those in as is. I mean, these are we can. This works because They're in screen space. You okay?
Sorry, yeah, I'm good.
All right. So let's just go. Let's just check the drawable object. Are we? Let's rotate point angle. Oh, I am returning back as and I'm literally gonna grab. In fact, I'm going to make I'm going to bring. So the issue that I was having is the function I gave you was returning in degrees. I'm basically going to add. So this is basically just don't convert. Okay, that's basically what's going on. Is that I am converting. So I'm doing the work, but it's being converted. The original function was converting it back to degrees, and then we're setting the degrees in something in radians, and that's why we're getting that crazy rotation rate. And that's a sign that something going again. Like the difference between a degree and a radian is like literally like 56, multiplication of 56. So you saw that little bit of movement, and it was going crazy. All right. So save here, cancel. And you can see now is now rotating correctly. Yeah, I think the one thing I'm going to do just to support us later on, just this will make sense, is that we will want again, we've got a draw, we got the drawable object has a tick. The drawable grid doesn't have a tick itself. Just I'm going to go in and basically there's a setup scene, tick scenes. I'm actually going to go in and going to be a tick grid. So the goal here is basically, again, it's basically public void tick grid. And I'm basically going to create another function, a public virtual void tick. So I'm going to add a tick here. Basically, I'm just going to call tick. We'll do an if. We'll do an if is ticking grid. Actually, if not, we can do a and then we'll just go up here is ticking scenes. And then this is a, again, and I'm just going to make these true to default out. This will help us in future labs so that, like if we wanted particular objects that we wanted to tick, rather than ticking the scenes, we can have the grid do that operation. So the idea here is that in future labs, again, here, we can do set up scenes, and then, literally we can do an override tick. So we could do a tick here instead, as opposed to each individual scene. So we could do something, something specific, with, something specific with. Doing something specific with the excuse me, we can do something specific with the grid here as app. So we've got so basically we're isolating all that other code that we've got and then implementing all this other code here instead. So there will probably be a little more work in terms of input. We'll probably have to do something for input later on. But for now, if we wanted to like move an object, and that's actually, in fact, let's do that right now. Let's grab the facing box. Tick. Let's just do something simple. This is going to be a position, and this is not part of the assignment. I'm just going to show you. Now we can go in position plus equals vector 3.1 times time dot delta time. So we're going to move 1 unit. So the box is going to be moving down the x-axis 1 unit. This is going to screw with the rotation. So just note that it's still going to be facing based on the origin. I'll let you figure out I'll let you figure out the answer to that later on. The extra credit. Have it face based on its position. So, but the idea here is I just want to show you, hey, now we can now took off like crazy. something's going on with this position. Let me just take out the rotation for right now. Oh, I just want rotation dot. Actually, let's do it just on the x-axis. Yeah. Let's just move down the x-axis. I think I may have been doing some. I was doing something with the z. I bet that might have caused something. Oh, oops, plus equals. There we go. So it's moving slowly. So let's go, we'll do 5 times. Crank up the speed a little bit. And we zoom out. So there it is. So you can see that there is the object. It's moving at 5 units, effectively 5 units a second, which is looks slow. I mean, we can. So here we go. We've got this in action now. Any questions about where we're going with this? What's going on? No. We'll be doing more things again with this. The drawing grid class will probably implement a bunch of booleans, and so we'll probably. I don't know if I we'll see. And now we're going to have to do something for input later on that you can then access input from that class. So the drawable grid class is going to be like the main point of input pulling. How that's going to look, I don't know right now. We don't need it for, again, right now, this is working. Let's get back to the rotation piece. Yeah, it wasn't working before because I was doing something on the z-axis. So it is still facing based on the origin, but it's not going to be correct. Like it's still assuming it's still at the origin and not at its point. So that is a thing to consider. I'll be honest. We would do the position first. And then it would be not the origin. It would be we would need a vector 3. So we use the screen position. So So this is where we would start. What we would actually need to do is vectors. Stream position is equal to drawable grid instance dot this is literally the grid to screen function based on its position. Yeah, this is actually how we would fix it, is to go use the because we'll take the position that it is on the grid, convert it to screen space. And then with that now converted into screen space, we can now grab, now we're going to say this versus the mouse position, which is also in screen space. So let's save that. I've done pretty and extra stuff, so. And now is accounting for its actual position. It's now rotating correctly based on that. So. This right here, doing what I just did, not required. Won't be required. This will be it'll be extra credit.
Is it moving away from the origin?
It is moving away from the origin.
Oh.
Yeah, no, its position is changing 5 units every second down the x-axis. When it was disappearing before, part of that I believe is because I was multiplying its position, so it was vector 1 times at delta time. I was affecting the z-axis, and I think that was part of the problem. So it was off the plane that we're on. So, all right. Any questions for me about what you need to do? I'm going to go through and just make sure. Yeah, let me go. Just let's do a public. Let's just get this cleaned up. Public float move speed is equal to 5f. So let's just, again, I don't, and then I'll do a public bool is moving. Oh no, I just want to put it inside. I might as well do a public. Bool is facing mouse equal to true. And just, just wrap this code into this. There we go. So just booleans to play with, just so that you have. All right. I will be giving you you should be able to do everything else. Let me grab out the empty scene. So this is we'll be using in another lab. So don't worry right now. All right. Any questions about the lab? What you need to do? It's pretty much we were building the plane as we were flying it in the air, but you're going to get some of the good amount of code. So don't worry. Any questions for the lecture video before I stop it? Show of hands.
None come to mind.
Okay. Show of hands. Are you in a good place with this lab?
I feel like I am, although I do still need to get caught up on the last one.
Okay.
Yeah,
Same.
same.
Okay.